So parts per million, or ppm, is equal to the mass of the solute over the mass of the solution. And remember that mass of the solution is equal to the mass of the solute plus the mass of the solvent. That times 10 to the 6th. And this is a factor that accounts for the million. Okay? So if we have a 5 parts per million solution of maybe chloride ion, for instance, that's saying that we have, if we'd had a gram of that solution, we would have 5 grams of chloride ion per 1 gram of solution. So that is 5 parts per million. Now, you see that the mass of the chloride ion is very small in relation to the mass of the solution. So you can see that the contribution of the mass of the chloride to the total mass of the solution is incredibly small. And if we're working in aqueous solutions, so in water, we can assume that the density of that solution is equal to 1 gram per milliliter. Okay. At room temperature, or 25 degrees Celsius. So in that case, we can, instead of having mass in our denominator, we can have volume. So if we convert our 5 part per million and use our density to convert the denominator to having volume, we'll see what we get here. We'll take the 0.00005 grams over the 1 gram of solution, use our density, and we will end up with, so the grams of solution cancel, 0.00005 grams per milliliter of solution. Okay. But that's not the most convenient way of writing this, and this is times 10 to the 6 to get ppm. Because writing so many zeros is just somewhat inconvenient. So if we convert our mass into milligrams, let's take 0.12345 grams. For 1 gram, there's 1,000 milligrams. And so that gives us 0.005 milligrams. Okay, we're getting better. And if we take our milliliters, so if we have 1 milliliter and convert that to liters, 1,000 milliliters in 1 liter, we get 0.001 liters. And now, if we divide 0.005 milligrams, 0.001 liters, we'll end up with 5 milligrams per liter for our parts per million. So a convenient way of thinking about parts per million, if you assume that the density of the solution is 1 gram per milliliter, and it's an aqueous solution, so 1 part per million would be equal to 1 milligram per liter. And this is just sort of a more convenient unit for converting to, say, molarity. Another way of writing this is that if we have 0.000005 grams of our chloride per gram of solution, and we want to do this all in one shot to convert this to milligrams per liter, we'll take our density of 1 grams of solution per milliliter of solution, we can convert the volume in milliliters to liters. We can convert the mass to milligrams. So, 1 gram has 1,000 milligrams. And let's see, grams of solution cancel, milliliters cancel, we're left with liters in the denominator. Grams cancel, and then we're left with milligrams. And so we should get 5 milligrams per liter, or 5 parts per million. It's also convenient to have this smaller number as opposed to writing something times 10 to the minus 6, for instance. We can do something similar with the parts per billion, ppb, notation, where parts per billion is the mass of solute over the mass of the solution times 10 to the 9th. And if we go through and we do the same sort of process, instead of going to milligrams of solute, we would go to micrograms of solute. And 1 microgram is equal to 10 to the minus 6 grams. Alternatively, 10 to the 6 micrograms is equal to 1 gram. And use that factor in place of our conversion to milligrams. And what we would end up with is that 1 part per million, assuming the density of water is 1 gram per milliliter and we're in aqueous solution, is equal to 1 microgram per liter.